All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, we left off with our hypothesis function, and this is an alternate way of how we could have written it, and we're going to pick up where we left off. So this is a simple representation when a hypothesis takes as input some input vector x, some humidity, and pressure for some day. And we want to predict an output, like rain or not rain, or 1 or 0, however we choose to represent things numerically. And the way we do that is by taking a dot product of the weights and our input. If it's greater than or equal to 0, we'll go ahead and say that the output is 1. Otherwise, the output is 0. In the hypothesis, we say it's parameterized by the weights. Depending on the weights we choose, we'll end up getting a different hypothesis. If we choose the weights randomly, we're probably not going to get a very good hypothesis function. We'll get a 1 or a 0, but it's probably not going to accurately reflect whether we think that it's going to be raining or not raining. But if we choose the weights right, we can often do a pretty good job of trying to estimate whether we think the output function is going to be a 1 or a 0, meaning raining or not raining. So the question then is, how do we figure out what these weights should be? How to be able to tune those parameters. And there are a number of ways that we can do that. One of the most common is known as the perceptron learning rule. The idea of the perceptron learning rule is to say that given some data point that we would like to learn from, some data point that has an input x and an output y, where y is like 1 for rain or 0 for no rain, then we are going to update the weights. But the big picture idea is that we can start with random weights, but then learn from the data, take the data points one at a time, and for each one of the data points, figure out what the parameters do we need to change inside of the weights in order to better match the input point. So what is the value of so that is the value of having access to a lot of data in a supervised machine learning algorithm. We can take each of the data points and look at them multiple times and constantly try and figure out if we need to shift our weights in order to better create some weight vector that is able to correctly or more accurately try to estimate what the output should be, whether we think it's going to be raining or not raining. So what does the weight update look like? We are going to update each of the weights to be the result of the original weight plus some additional expression. So here, and to understand this expression, y is what the actual output is. In a hypothesis of x, the input, this expression here, hwx, is going to represent what we thought the output was, or what we thought the input was. So this is the actual output, and this is what we thought the input was. And this is the definition of perceptron learning rule here. It's just written out more factually without all the extra bells and whistles. Given data point x, y, update each weight accordingly to, and we have the weight I equals weight I plus some expression. Now, if we wanted to, we could represent the original equation like this: A actual value, take away estimate, and that'll be this part here. The y take away the estimation. So the y is the actual, that's what we replace the actual value with, and this is the estimate. That's where we place the estimate here. Now again, we did take a lot more notes, but I'm not going to go into everything because I don't want to get jumbled up and I don't want to have you guys confused trying to follow along with me. But yeah, I'm definitely going to keep you guys posted every step of the way, and we'll pick things up tomorrow. But for now, you know the usual. It's the Python Poppy. You guys stay Gucci.